mostly the diagrams that we discussed lastly, and we said we have 9 diagrams, but we must classify them. And when you are classifying them, we must know where each and every diagram is classified to and why we need to classify them. So I want to share the notes that I have here because they will assist us maybe to get more clear on various aspects of these architectures that we have. So to start with, I'll go back to UML diagrams, and I think according to the CAT, it was okay because most of you are able to answer questions on UMLs, and we had no issues. And I think maybe what we can maybe try to explain further is when we were talking about structural thing. And I think you look at the question that I asked, there is somewhere we were supposed to highlight some structural thing. So I think the notes are very clear because we said one of them we have classes, we have interfaces that are mostly used to create a platform that the users will be able to communicate and be able to cooperate with each other. We have use case. Mostly when you're talking about use case, we talk about activities or the activities that are supposed to be done in sequence. Then we have active class. That is a class that is now dominating some attributes or functions to others. Then we have the component, and this is the physical presentation of the system that we have. Then the node is the system itself, the physical element of the system. So I want us to go directly to modeling of a system architecture. And I think up to now, you know what is modeling because we said a modeling is a presentation of real or reality or real presentation of objects. Where object, we said it has behavior, it has identity. And that's why we say that for you to create a system, it must either follow some different categories. And I think I want to give this using the PowerPoint so that we can understand those classification of these models that we have. And one of them, the one that we have is what you call the static. So the first one that we are supposed to have as a model, so we are looking at the models. One of them is what you call the static. And if you look at the static, we are looking at something that is not changing. Mostly maybe we look at one has a certain characteristic, but those characteristics are not changing on that independent object. And we'll be looking at one of them. We'll be looking at what you call classes. Then we look at what you call inheritance of these classes. So mostly we are supposed to look at classes as a static model. Then after that, we look at what you call the behavioral model. And the behavioral model will be able to look at what you call the use case, and what you call the activity diagram. Remember, it is portraying some aspect of characteristic that are supposed to perform or to give an action. So that's why when you have two objects, when you combine them, how will they create an action? So it's like we are combining A and B, and when you combine A and B, which action? So you have A, and then you can have B. So which is that action that is here? So that's why we say that we need to use some relationships. And these relationships that we are supposed to have, we'll be able to look at them. One of them is generalization. We look at realization of this. Then we can look at association as a relationship. And if you look at the models that we have here, first of all, we can work with these two, because the next model that you always have is what you call the dynamic model, where we look at what you call the sequence diagrams and maybe the collaboration diagrams and other diagrams that we have. So for now, I want us to go to static and behavior or behavioral. But before we go to behavioral, we need to look at now the presentation of these relationships as per the question. If you look at the question that I asked in CAT. So that's why we are saying the models will be able to assist us to come up with a very clear presentation of these elements, given that they have some relationships. That's why we are saying the architecture of a system is the organization of structural and behavioral elements. So when you look at structural, we are looking at now the outside of a system. It's like now you look at maybe a system. We are seeing this is an e-learning system, or this is a registration system. But what are these behaviors? What are the behaviors are we supposed to have within the system? So if you look at most of these systems, you can maybe say that a structure is that organization of the system registration. But what about behavior? So it is registering student. How many students per minute? So you look at that. That's why we are saying it is concern of usage, concern of functionality, concern of performance, resilience of these systems. And if you look at the resilience of this system, is able to work within the confined resources, and it's able to give you what you require. If you look at now registration, it's not supposed to give you maybe hospitalization, maybe if you have that function. So we have said it has function. What are the functions? Registering. What are the performance? The performance is very fast or steady. That. Resilience is it giving you whatever is supposed to give you within that. Reuse. Can you reuse that code that you are using so that you can come up with a clear system? That's why we need to look at the diagram that represent these models. And the first one, we always look at now the use case, which is now at the middle. And when you look at the use case as a middle, this is where we are looking at the activities that are done. Like now, I know you have proposal that you are presenting. And at the moment you are presenting those proposals, maybe you are coming up with a library management system. But within this library management system, you have to ask yourself, what are the function? What are the functional requirements? What are the non-functional requirements? And when you talk about the functional requirement of a system, maybe you talk about functional. It is what the system will do, or what the system is supposed to do. But if you look at non-functional, we are looking at those functions that are not relevant even to the system. Like now, if you look at now, maybe availability. It's not a must that this system is available in that market. Having a system, but there are some functions that are not available within the system. Maybe accuracy. It's not a must that you have a system that is very accurate. Remember, that's why you always construct system each and every time that you come up with a system. Like now, I know you're not coming up with a new system in the market. You are coming up with a system that has already been used in the market. But now, you found that now this system was not accurate, and that's why we are trying to provide some element that can make it very accurate. So in this case, that's why we're saying use case, we'll always portray some activities that are supposed to be done. So those are functional requirements. But what are we supposed to do with those activities? Maybe we can design those views, we can implement them, we can process them, we can deploy. And that's why we are saying use case view include the use of case, the use cases and the interaction that describe the behavior of system as seen by its end users, analysts, and testers. So we are looking at now the behavior, the activities that are supposed to be done by this system. But if you look at now the design view, it includes classes, interfaces, what you provide to the system, to the users, so that they can use. I know that you use registration system when you're registering for units, but the moment you register that, in some cases, we don't even mind how the system is registering you. What we mind is, can it provide an interface that is user-friendly and that can be able to solve problems that are within the domain, which is now in ZTech University. Then the next one is the process view, and the process view, what you're supposed to look at is we need to look at now the threads and processes that form the system. So we are looking at some connections of the system, some elements that are connected together to form a system. Then you can implement. That is now when you take the system to the use. So include component and files that are used to assemble and release the physical system. Like now, if I use this, if you're using Java programming, maybe I'm using Java programming. If I'm using Java programming, I can use one of the implementation view that is called a jar file. I can use a jar file. And this jar file is the one that now you implement or you embed within your mobile system or within your computer, and then you can use that application. Like now, if you're using your mobile phone, your mobile phone has some icons, and those icons that you are provided, those are apps or applications. And because those are applications, somebody created that application. But the moment he was creating those applications, the only thing that he required is to provide a jar file that the user can use. So that is implementation, where deployment is when the system has to be used in the organization. So include the nodes that form the system topology on which the system executes. So we are looking at now the usage of the system in that case. So maybe to go direct to what we are supposed to cover today, we were supposed to look at now the types of UML models. That's why I've practically explained what are models and what we require within a model. So you need to design, you need to do some processing, you need to do some deployment, you need to do some implementation. So that's why I expect you, the moment you are coming up with your own system, you have to design, you have to create processes, you have to manage these processes in the execution, and you have to make sure that the system is able to work within the confinement of these requirements. And I think now, up to now, you know what are models, what are the requirements of the models, what do you need in a model when you are presenting this case within the system. Because in this case, if you can come up with a system, and this system is not providing what you call the process view, the executions, it is not even providing the design view, how it's supposed to be laid out, the interfaces, not even providing the implementation. That is now provision of files that can be used in the execution. It is not even providing some usage in that domain. It's like now you come up with a system but cannot be used in the institution. So if it cannot be deployed in that, that is null and void. Now, for you to come up with that system, what are the requirements? That's why we are discussing types of UML models. And when you talk about types of UML models, Unified Modeling Language, one of them, we have said we have three. One is static, we have behavioral, and then we have dynamic. But let us first of all start with the static modeling. And when you talk about the static modeling, we are saying these are the things that are not supposed to change in a presentation. And that's why I remember I said, suppose we have a student, and this student is supposed to do some provision of other activities that are portrayed on that. So we are looking at now something that is not changing as a student, but that student should do something. So you not change as an object, but they have to be modeled in a way that the users will be able to understand them. That's why we have said one of the diagrams that you can have is what we call the object diagram. So you can have the object diagram. And when I use the object diagram, maybe I can use paint. In this case, we can say we are having something like a student. So this is a student. So we know that if it is a student, The student should have behavior, should have state, and should have identity. That is just a simple presentation of what you call an interface. And this interface is the one that we are saying this is now an object. So this becomes now a presentation of a student. But we know that inside a student, we have behavior. Inside a student, we have a state. And inside a student, we have an identity. But how will you be able to present that in a more advanced way? I remember when I was explaining what is a class, I remember we said this is an instant of an object, instantiation of an object. And I remember when we are saying, if you provide a class, like now I'm providing using a certain programming language, I provide a class. I know you have done C language. Maybe you can answer that. Yes, members. Doreen, can you switch your mic, please? Yes, thank you for that. So what we are saying is, I think up to now, you know C programming language. And because you have done C programming language, you know how to declare a class. Do you know how to declare a class? I think you can use an SMS. You can send a message here, or maybe you can use a mic. You switch on your mic and then you communicate, please. Anybody with an issue on use of a class? How to declare a class using C language? That is the language that we know currently, because I know you did that in semester 2. Doreen, can you answer that? Do you have an issue?
No.
So you know how to declare a class?
Yeah.
Okay, Evans, do you have a question on that? Is Evans in? Evans, Kemani. Okay, let's go to Grace. Grace, do you have any question? Okay, Kemani has answered. Grace? Okay. Magara Kefan? Kefa. Richard, Teddy? So if you have a question on that, maybe we can clearly maybe show you on how we can be able to declare a class. But because now I'm teaching you on this, I wanted maybe to see whether you know it. If you don't know, maybe I can start from scratch how you are supposed to declare a class in programming. But for now, I think maybe I can have a class name here. I can have a class name, and I always have to open that. And when I open, here, this is where we have data members. Data members, and then we have some colon. Then at the end here, maybe we can close where we have still semicolon at the end. So what we are saying is that if you declare a class called student, we are saying class student, but let me use a PowerPoint for the sake of that. So if you declare a class, we are declaring a class student, and this student is having a data member. Maybe we can have int age. Then we can have maybe char name. Maybe we can say this name should have not more than 3 characters. And then maybe we can close this. Then we close with a semicolon. So what we are saying is that this class has a class name, which we can now say this is an object name. It has an object name. Then within here, all these that we are having here, which we are calling data members, all these that we are calling data members, maybe we can say These are either operations of this file. We can have attributes. So we declare operations here, and we still declare attributes here. So it means if I want to come up with a class, or if I want to design a class, and this class, I want to call it maybe class A or class B. So in this case, I need to have 3 sections. So I need to have the first section. I still need to have another section. I still need to have another section. So the first section that we are having here, maybe we can edit. Maybe I can insert a text box. So the first one that I'm supposed to have here is what you call the class or the object name, or the class name. The next one that I'm supposed to have, which is now here, is now the attributes. And the next one that I'm supposed to have here is what you call the operations, if it is a class. So for this case, we are saying this one has an identity. So here, we can also say that we have an identity. We have an identity. So we have an identity. Then within here, we can still say, we have maybe the state and the behavior. We have the state and the behavior. So this is the state, registering. Registering is the state. E.g., maybe we can have registering. Registering. This person is registering as a state. Behavior is how we are supposed to register the system. So we can say these are maybe operations. Operations. So I need to key in my name, that is the state. I key in my registration number. Then the operation that is being done there now becomes what you call the behavior. So here we can say we have behavior. Here we can say we still have behavior. Here we have the identity that we are supposed to have here. So in this case, let us try to understand if you have a class and this class is supposed to be defined, we need to see their presentations. So let's assume we have student. Let's say we have student. And I want to use a paint. So we are saying we have a class called student. So my diagrams are not clear, remember. So here we can have student. Allow me to use short forms. So which is the first element that we are supposed to have within a student? So which is now that attribute that we are supposed to have? Maybe you can have the ID number. We can have the course. Looking at now, I'm not looking at now the database where we have the primary key. So here I can use the ID number, which is supposed to be given as an integer maybe. Then we have another one, which is the course, which can be either a char. Then here we need to have some operations. Maybe the student registers to register. So when you're using a method, we use that. So another name for operation is the method. So this one can be a method or operation. Maybe the student maybe can do what? Book. So we have an operation called booking. So in this case, the moment you are creating your own system, we are using Java programming. Maybe we are using Java, we are using Python, we are using C, we are using C++, we are using Debbie, we are using other programming languages that we have. So in this case, we must come up with our own method that is supposed to do something. That is supposed to do something through the use of these attributes. Through the use of these attributes. So the moment we are defining that in programming, and we want to produce some attributes that are private. Suppose you want to come up with an attribute, or we want to come up with attributes that are private. So how will you provide them? So private attributes. Because that is now, if you can understand in programming, these are the ones that we say, these are scopes. So we have scopes of variables. Scopes of variables. Maybe you have private, we have public, we have static, etc. But now let us first of all emphasize on this. So the moment you talk about private, we are saying that program that is within a certain domain cannot be used outside that domain. So in this case, we use in attributes. In attributes definitions, we always use a minus. But for this one, because now we are saying it is used within and outside, so the attributes are defined with a positive, or you can leave them empty. So like now, if I have ID number, this ID number is private to only that student. So I use a minus. Then here, I can use an integer. That is the declaration within a class. Then, if it is now the other attribute, which is now the cause, maybe it is that we have the cause, and this cause should be a character. That is the definition. So to represent with, maybe we can go back to this class and maybe we try to understand what we have here. So here we are saying minus admission number or ID number, which is supposed to be given as an integer. Then the next one that we are supposed to have is what you call the cause, which is supposed to be given as a char. But now this one is given as a minus because it's private. If it is an operation, here we have seen one of the operations that we can have is registration. So you can use register. And then we open that. Maybe we can say we have book, and or maybe we have booking, and then we open that. So in this case, what we are saying is that these are, the whole of these are public. So you can either a plus sign or you use this as a plus sign. So if I want this one to be used in the entire programs, maybe you have another class of a student but requires some implementation of the parent class, now you can use that as a plus. So in that case, so here I can maybe say I have a student. So I have a student. So I have a student, but this student has ID number and has a method called registration. So in this class, if a class A is able to inherit to another class, so that is now why we need to do some relationships. So that's why we are saying it is static. It's not changing. That class will never change. It is that class alone. So let's look at now the relationships that are supposed to be seen on these classes that we have. One, we have inheritance. We can inherit. It's like now we have a parent, a child inheriting some attribute from a parent. We can depend. Maybe a child is depending on a parent. Association. Maybe class A and class B, or the parent class and a child class, they have some commonality. There are some things that they must share. Realization, there are those that has to be portrayed within the presentation, which are more superior than the others. So in this case, if you look at the first one, we are looking at inheritance. And I think this one is not new to you, because when you talk about inheritance, we are looking at one class acquiring some properties of another class. And I have a good example here where we say we have a parent, and we have a child. So we have a parent, and then we have so the moment I tell you, maybe in an exam, can you present an inheritance using a certain class? So in this case, we will be able now to understand we have to present a class like this. We have to present like this. So meaning that this class should have 3 sections. 1, 2, 3. One is the class attribute, and the next one is for the operation. If you come to this, let me maybe use this. We still have the same. So I think maybe we can. I can press enter so that we can move to the next page. So if you look at this, maybe we can try to come up with a presentation for that. So we're looking at this now. You have a class called parent, and you have another class called child. But one class is inheriting the other. So a child class is inheriting a parent. So when you are inheriting from a given class, the arrow should be pointing to the super class. So in another one, this you can call it the super class. And this one you can call the subclass. So the superclass is the parent class, the subclass is the child class. So meaning that this class is the one that is giving some attribute to the child, or maybe the child is depending on the parent. So that's why you can see the child is depending on the parent. That's why the arrow is pointing to this. If you look at this, same case, you have another one, which is now called attributes, person. We have a class called person, and we have another class called student. Student is a person, but a person cannot be a student. So this means there is a superclass where the class student should depend from this. Let's just have another example. And we have a class called shape or shapes. Then I have a class called rectangle. So in this case, if I tell you to present a class, so automatically you are supposed to present this class. Allow me to use a table. Okay, let me insert. Maybe I can insert a shape, and maybe we can allow me to use only without separating them. You allow me to use these shapes without separating them, because now I think you have understood that. So you find that this class, which is a superclass given to this. Even if maybe I use, because I can use any presentation like that, which is a superclass here. Maybe class, you can tell me which is a superclass, or which class is super. Okay, I have seen a question on a repeater on declaration of a class. I will repeat that, please. So maybe you can allow me to repeat that. Allow me to repeat that before I ask a question that I was asking. I was saying, when you are declaring a class, you can use any programming language, but I have preferred to use a C programming language. And when I'm using a C programming language, I think you know the syntax of declaring a class. You have a class name, then you have data members, and these data members, what we are saying is where we have operations and attributes. And then we can close, and you have a semicolon. Here is where we have a tag, which is optional. We have a tag which is optional. So for now, I will not use this. Even if you're using Python, even if you're using any other language that you can use, maybe Julia, which Julia is mostly used for modeling. Currently, that is the current programming language that we have in the market for programming. Even if we are using R programming language, the same case, we declare the class the way we declare, but now the syntax changes. So in this case, we are saying we have attributes. So we are assuming that we have a class called student. And this class called student, the student has age, and the student has name. But we can still use some other operations. That's why I said, for you to present an interface, for you to provide an interface of a class, we need to use this interface. This is the interface that we're supposed to use. And this interface that we're supposed to use, it has 3 sections. One section is student, which is now where we have the class name, we have attributes, and then we have operations. But the moment we are using some operations, I've said this operation can have a scope. And that's why we have said, can we have a scope that is private, or can we have a scope that is public? I know that in programming, because for now I'm not teaching programming, we have the other one that is called protected as a scope. When you go to C language, we say these are global, and we have what you call the local declarations, global and local. So for this case, we can maybe try to interpret and say the presentation of what we have within our main interpretations, we have to look at now the class itself has a private data or attributes, or has a public attributes. And when you are presenting a private attribute, I've said we use a minor sign. But when you are using a public, we use a positive attribute. We use a positive sign. That's why if you look at this class that I have defined here, we have said we have a class called student. But this class called student, it has 2 attributes. And one of the attributes I have said it's a public, the other one is private, meaning it can be used within the scope and outside the scope if it is public. The other one is operations, where in this operation, I've said it is positive, because when you use positive, you can use it in the entire program. So in this case, that's why we have said we can use states. This is the state. The state is register. But now the operation or the behavior is registration. The student is registering as to a certain course or a certain unit in that. I hope we are clear now. Narasha, I think I am clear now. Is there any question up to that point before we proceed? Narasha, and any other person who has an issue, please. If you have an issue, please ask a question. I will answer. Okay. Okay, any other question? Any other person with a question? So silence means it's okay, eh? So that's why I was asking a question, eh? If you look at this diagram that I have here, I've said most of these classes now, they are supposed to create some relationships. And these relationships that we are supposed to have, one of them, we can have what you call the inheritance as a relationship, dependency, association, and realization. And remember that there are some specific arrows that we are supposed to use in each and every relationships. So these are relationships that are mostly used in UML. In most cases that you can be able to understand when you talk about relationships, it's like I am saying, your parent, you have some relationships from your parent, maybe color, maybe size, maybe the look, the way you talk, maybe those are the relationships that we have, inheritance. And I want to emphasize mostly when you talk about programming, because we say, when you talk about inheritance, we say inheritance is, we use is, or has. Is, has an attribute, is a relationship. So in this case, we now be able to understand the presentation of what we are supposed to have within the data that we have. So that's why if you look at the notes that I have said there is an aspect of one class acquiring the properties of another class. So there is a parent class, and that parent class is the one that I have said it's called the superclass. There is another one that is called a subclass, and that subclass is the one that we have said is a child class that we have. So we have saying the class that passes over its property to be inherited by another class is known as the parent, or the super, or the base class. Well, the one that acquires the properties of a parent class is known as a child, a sub, or a derived. And I think you are doing OP1, if I'm not wrong. Am I wrong or right? Are you doing OP1? Somebody can answer yes or no. Are we doing OP1? Are you doing OP1? Please, can you assist Anna Kavinya? I think you have joined. Okay, so I think I have gotten an answer from okay, I have two people have said that it's okay. So if you look at OOP, object-oriented programming, in most cases we say that we have derived class. Why? We are deriving some attribute from a parent class. That's why we are saying, if you look at this diagram that I have here, we have a parent class, which we have said it's a superclass, and I have a child class. So it's like we are saying, maybe the parent of Kamau is John. So we can say John Kamau, because Kamau is the child, John is the parent. So what are we deriving? We are deriving some attribute, maybe the color, size, and many other things that we can have. So those are the attributes that we have. So that's why we are saying the child class can inherit all or part of the properties of a parent. It's not a must. I think you have, maybe you can look at your brother. It's not the same way. Maybe we can say your brother looks like you. No, it's not the same. Maybe you can have your brother, but your brother is tall, but you are slim. Big, you find that your brother is big, but you are slim. You are small, but the other one is tall. So it's not a must you get all the characteristics, but you can still have some other classes. So you can have some class that is now getting some attribute from another. So in this case, so that's why we are saying this is a single class, and that's why I have said we use as a relationship. When we are saying parent class and a child class, it's like you are saying a person and a student. So a student inherits some attribute from a class called person. And which are these relationships that we have? So before we go to these types of relationships that we have here, I was asking a question. Now, which is now a derived class here? Which is a derived class and which is a superclass? I think we can answer with the one which now is a superclass. And when I'm using this arrow, when I'm using this arrow, where will this arrow point to? Will it point to rectangular or will it point to shapes? So please, a class, you can answer that, please. So we are having a class, I will repeat that question again. We are having a class called rectangle, and we're having another class called shapes. But one of the class is a parent class, and the other one is a child class. So which is a parent class? And where will the arrow point to? Where will the arrow point to? So I think the question is clear now. So somebody can answer that, please. Okay, I have gotten an answer from Magara. So the arrow will point to rectangle. Is there any answer? Or who can second? Maybe we can second that, or maybe we have another answer. So we are now nine users. We are 8 users. So somebody can answer another. So this is a question. Where will the arrow be pointing to? Will it be pointing to the shape or rectangle? And which is now a superclass? So class, please, I'm waiting for an answer. So you can either use your mic. You can use your mic. So I have the first answer. We'll be pointing to the rectangle. I will judge the question. Okay, shape is a superclass. Yes, Doreen.
The arrow will point towards the rectangle.
Okay, now, okay. Okay, I will comment on that. So I think I can explain that. If you look at these two classes that we have here, one class is a parent class and the other one is a superclass. If you look at a rectangle is a shape, but a shape is not a rectangle. So you can see that there is one class that is more superior than the other. So the class that is superior than the other is the superclass. So the superclass, I think I've gotten an answer from Magala, and I think the answer is okay. So I can concur to that. So the answer is okay. The answer is okay. Shape is now a superclass, but for the answer that you have already answered to the rectangle, the arrow will not point to the rectangle. The arrow will point to the shape. Because rectangle is the one that is now borrowing some relationships from the shape. If you look at this example that I have here, I'm having a parent class. So automatically we know that if we come up with a clear representation of what is a superclass and what is a subclass, if you understand this is a superclass and the other one is a subclass, so automatically the arrow should point to the superclass. That is our own interpretation. And I think I'm clear now. So according to our scenario here, the arrow will point to the shape. So we can say rectangle has some attribute of a shape. Rectangle is a shape. So we can use rectangle is a shape, but we cannot say shape is a rectangle. That is not a correct grammar. And if you look at this, I think I have said, hence, inheritance is sometimes known as a relationship. So if we can say parent is a child, that is not okay. Child is a or has some attribute. Student is a person. It depends with the presentation of your scenario. So child has some attribute of a parent. Student is a person. Student is a person. So I think I'm clear up to that point. Am I clear up to that point now? Am I clear? Irene, are you there? Okay, Teddy, okay. Is there anybody with a question after that point? Okay, events have not understood. So I can still repeat. I can still repeat so that Evan can understand. So what I'm saying, I will still use this presentation. So the first thing is to understand that inheritance is when a class acquires some properties of another class. Now, Is it possible that if you are having a class called parent to acquire some characteristic from a child? That is not clear. That is not okay. So a child inherits some properties from a parent. A student inherits some properties to be called a person. You cannot be called if he or she does not inherit some attribute of a person. So it's like now you back. So you are not a person, you are a dog. So in this case, you must first of all come up with a very clear scenario presentation of which is a superclass and which is a subclass. So in this case, we have said a superclass is a class that is now delivering some attribute to a subclass, or that is giving some presentation of attributes to this. The parent class has powers to authoritate the executions of all functions that are in a child class. The child class has been restricted some executions that are unapparent. So that's why I have said, if you look at this example that we have, we are saying we have rectangle and we have a shape. So we know that a rectangle is a shape, but a shape is not a rectangle. That is the opposite. So in this case, we are saying this becomes the parent class and this becomes the child class. This becomes the superclass and this becomes the derived class. And because this is the derived class, the arrow should not point to the derived class. The arrow automatically points to the parent class. That is the presentation. If you look at this example that we are having here, we have a person and we have student. So the arrow should not point to the student. The arrow should point to the person, because a person is a subclass. And that's why I have said there is a relation in it. And that relation is a relation. So we cannot say a person is a student, but we can say a student is a person. We can say a student is a person, because there are some properties that are from the person, so that you can be called a person. You need to have some attributes that are within a person. So when you're defining a class using a given programming language, so automatically we can now say maybe we are extending. So we can extend some attributes, extends attribute of a rectangle, or extend attribute of a person in that. So for this case now, we are implementing an implementation, an interface for an implementation. And that's why we are saying, if you look at our example that we have here, we have shape and rectangle. So rectangle is a shape, but shape cannot be a rectangle. So we cannot say shape is a rectangle, but we say rectangle is a shape. I think I'm clear up to that point now. Evans, I think I'm clear now. Evans, okay. Richard, I can see you are typing. I can see you are typing, Richard. Is there any question? Yes,
Okay,
Richard.
sometimes you are using the a bit confusing me.
Which
Like
term?
when you say a rectangle is a shape, but the shape is not a shape, what is it?
Okay, what I'm saying is, if you look at a shape, we dominate some attribute in a rectangle. We dominate some attribute from a shape. That's why we say, let me write it so that it can be clear. So we are saying Just a minute. So we are saying is a relation. That is the relation that we are supposed to use. When we are now interpreting our representation here, we are saying a rectangle is a shape. But now, if you try to twist, and we say, maybe we can have another example here so that we can understand. We have this shape, we have this shape, and we have rectangle here. And then this arrow now points on the other side. Let's say this arrow now points from shape to rectangle. And now we are saying we use a relationship. And this relationship, now we are using is a relationship. So in our own case, before we come even to this, if you look at the example that we are having here, we are saying a student is a person. A student is a person. Why is this student a person? This student is a person because the attribute that you find within a class called a person are the same attribute that we find within a class called student. That's why we are saying this student will be called as a person if he or she has some attributes or some behaviors that are within a person class. That's why I was saying I cannot come here and say a person is a student. I cannot say a person is a student, but it is right enough to say a student is a person. Let me come back to my question here. When I say a rectangle is a shape, and then I say, because now this now becomes the parent, I think I need to write this. So this becomes the sub-class in that. But if you look at now this class, on the other side, this becomes the subclass. If you come to this, this becomes the superclass. But if you come to this now, becomes a superclass. And I think it's now clear for you to differentiate a superclass and a subclass. Given that, if you look at the notes, the parent is the superclass. And being a superclass, the arrow should point to the parent class. So meaning, if I use my example here, now this becomes the superclass, and this becomes the superclass because the arrow is pointing to the rectangle. So for me to use this, so we can say shape is a rectangle. That is very wrong. That is very wrong. Because a shape will never derive some attribute from a rectangle. But a rectangle is the one that derives some attribute from a shape. Are we getting that? Are you getting now, Richard?
Yes, I can understand, even though I did not get everything.
You did not get what?
Everything, but I understand.
Okay. If there is a question, you can ask, because now these ones, you need to still use them in your project, please. Don't hesitate asking a question. If you have not understood it clearly, please ask. Please ask. Richard, Sidio.
You can repeat it the last time.
Oh, the last one. Okay. Let me repeat the last one. So what I'm saying is that, and I will repeat from this point. I will repeat from inheritance. Remember we said we are saying we acquire some properties from another class. And we have said through that, we have derived some two classes. One class is a parent class, and the next one is a subclass, which is called a child class, as it's written here. Superclass and subclass, it's me who have added that. But if you look at this, we are saying in inheritance, it must have what you call SR relationships. And if it is having a SR relationship, it means the parent class, because it's now the one that is now giving some attributes to a parent, or the child is the one that is deriving some attribute from a parent, the arrow should point to the parent. So when you point to the child, it means this child class is the one that it's the one that now becomes the superclass. It means that this is now the dominant for everything. So a parent cannot move or maybe cannot execute without this child. But for this case, because now the arrow is pointing to the parent, a child will never execute if the parent attributes are not active enough in the execution. So that's why I've given an example here, and I've said we have a person and we have a student. So this student is a person. Remember, we are using is. And when we try to alternate, and now this arrow point to the student, as I have already explained it here, we are saying if this is a subclass and this is a superclass, if you alternate the arrows now, the shape now becomes the subclass, but the superclass now is the rectangle. So in this case, if I tell you to interpret the classes that we have, we can say a rectangle is a shape. A rectangle is a shape. But in this case, because we are moving from a child to a superclass, we say a shape is a rectangle. And that's why we are saying this is very wrong. The whole of this is very wrong. We cannot say a shape is a rectangle, but we say a rectangle is a shape, because shape is the one that has everything of that rectangle. And that's why we need to try to interpret this. This is a single relationship or a single inheritance. And that's why if you look at the notes that we are having, of which I have sent this note on your portal, we are saying a single inheritance, a child or a child class inherit properties from a single parent. So we don't care how many attributes, how many classes we are having as a child. We can have millions of them. It's like now, if you go to your family, how many children do we have? So there are maybe two, but how many? We are looking at parent. Parent is mother and a father. So we are looking at parent and children. So you have child one, child two, child three. But they are inheriting some properties from the class called parent. Let's still come back to this shape, and I want to add another one. Maybe I add a circle. So in this case, allow me to use another slide, and I still copy this. I still copy this, and I paste here. Sorry. So I use this, I copy. Sorry for that. Maybe we can, maybe let's use the same area because I want to interpret this single class. So we are saying if this is the shape class, which now becomes the superclass. And then we have another one here. We have a class called rectangle. And we have another one. Suppose we have another one called circle. So here we can have another one class called circle. So we are saying this is a class that has two subclass. And because it has two subclass, this subclass, we can say the arrow should point from the circle to this. So it's the same as saying we can move this and we point to that. Because these classes are sharing some presentation, that's why we use
Okay,
about
excuse me.
Yes?
We cannot see the screen you are sharing, please.
Oh, okay. I'm sorry. So I think now it is clear. So I think you can see that now. Can you see that now?
Yes.
Okay, so what we are saying is, if you look at the class representation, there is somewhere I've said we have two classes. And one class is a one class is a parent class, and the next one is a subclass, and the next one is a subclass. So in a single inheritance is when we have one parent. We have only one parent, but we can have 2 or 3 child or childrens. So in this case, if you look at this presentation that I have here, we are saying if we have a class called shape, which is a superclass, and we have another class that is called a subclass, which is called rectangle, and we have another one called circle. So these two classes are inheriting from shape. And because they are inheriting from shape, we can say these two classes are sharing some attributes or they are sharing some methods. So for you to present a single class or a single presentation of inheritance, that's when you open the first class, the second class, and then the arrow points to the superclass, meaning these two shapes, these two shapes that we are having here, they are inheriting from a class called shape. That's why we are saying, if you look at this explanation, a child or a child classes inherit properties from a single parent, But suppose now these classes are inheriting from multiple parents. Maybe we have 2 parents, but there is only one child in that. So a child inherits property from more than one parent. So it's like now you look at maybe a family that has only one child, but now we have 2 parents. So if you look at the properties that you find within this child, they are the same properties that you find within a mother and within a father. So that becomes a multiple inheritance, meaning this is where we can now change the arrow. Maybe we say there are 2 parents, but these 2 parents are deriving, they are now inheriting or they are now distributing some properties to only one child, which is called the multiple inheritance. So the only thing that you need to understand here is how we can differentiate these classes in a presentation. And if you look at the arrows that we have here, you can see there is a child class here. And this child class that we are having here is now inheriting from parent 1 and parent 2. So you can see the arrows are pointing to the first parent and the second parent. But there are other inheritance, because we can have multiple inheritance or what you call multi-level inheritance or hierarchical inheritance. At the moment you are using this, I have a diagram that is not clear, but I'll make it clear. So we are having a class here, and this class is inheriting from another class. So you have a parent class, you have a child class, which is inheriting from another parent of a subclass, and this subclass is inheriting from a parent class. It's like we are having a tree. Maybe we can have a tree here, and we say, suppose we have a grandfather. We have a grandfather here. So this grandfather has one child. So this grandfather has one child, and this person, we call him or her a parent. Then this parent, so we are looking at now a grandfather. So this child, this person is a grandfather of this child. So it means, irrespective of having a parent, there are some properties that you have already carried from your grandfather. So in a simple way, what we are saying is, most of the attributes that you are now carrying from a parent, from a grandfather, just a minute so that it can connect, there is an issue. So what we are saying is that if a grandfather has some attributes, maybe we have an attribute called X, we expect this attribute to be within a child. So if this parent, a grandfather, has an attribute called X, we expect this child to derive this attribute called X from a grandfather. So meaning, this child is deriving some attribute from a grandfather because of her parent or his parent. So that's why we find that now, maybe somebody has two children or has one child, and we say, this person looks like somebody X. And if you look at now, if you try to trace that, you look at now, that is a grandfather of that child. So we are not saying that we cannot now have other children. We can have another child here. But this child is not a must to have an attribute of this grandfather. But there must be one of a child who has some attribute of a grandfather so that it can be called what we are calling it a multi-level inheritance. Meaning, where there exist several layers through levels of inheritance. And these are the levels that we have talked about. And these multi-level layers or inheritance are the ones that will now introduce us to what you call hierarchical inheritance. And when you look at the hierarchical inheritance, it's the same class that I have explained here. Meaning, we are having a parent class, but this parent has two children. Then these two parents, these two children, so we can say we are having a parent X, then we have a child Y and M. So this child M and N, they have another child. So meaning, the attribute that you find here from this person and the attribute that you find from this person are the same attribute that you define within the child that you have. So let's have an example. Maybe if you go to your home, you can have your brother. Maybe I can use another new interpretation here. Maybe we are having a parent here. Let's use a shape here. So we can have a parent. But this parent has two children. So we can say this is child 1 or this is a sister, and this is a brother. So if you look at this, we are looking at now, there is some inheritance here. And maybe we can try to come up with this inheritance. And maybe we present something like this. Something like that. So this arrow should point to this. So meaning, the attributes that you find within your sister, if now you are talking about a brother, you have a sister and a brother. So the attributes that are within a sister, if you get a child, maybe this you call it child of your sister. Child of your sister. So this is a child that your sister has. So the attribute that you find within this child are the same attribute that you find within the mother of this child and the uncle of this child. So meaning, if this person is tall, we can say this child is tall like her, like his uncle. This child is big like his mother. So in this case, we are saying we have dominated some attributes from two children where in the end of facilitations, we did not create the facilitation of this person who is called brother. So the sister came up with this child, but through that, he dominated some attribute from the uncle. That's why we find that now we have a chain of inheritance. And this chain of inheritance is when you have only one parent, but this parent can produce multiple inheritance. So that means the attributes that you find here are the same attributes you might even see on this grandfather parent. So meaning, if this child is tall, it is possibly that the grandfather of this child is tall, or the brother is tall, or the sister is tall. So there are some attributes that are inheriting from another class. So in this case, that's why we are saying it combines all the above, it's not hybrid, inherit relationships that are formed an upside down tree structure. An upside down tree structure. Meaning there are some attributes that are coming from the far object or from the farthest object. And the farthest object is the child of your sister. If you can look at the child of your sister, we don't have any relationship. We cannot say that now. If you look at the normal interpretation, if your sister has a child, we cannot say that this child looks like the brother. But now here, we are saying the child now looks like the brother of your sister. It is because now there are some presentations because of this parent. So the parent is the one that is now bringing all these inheritance. And these inheritance are from the sister and the brother. So at all, we find that if this is where we are having 2%, this year we are having 20%, we must have more than the percentage that we have within a sister and a brother from a parent. So you find that this child has some attributes that are coming from a parent of these two children. Meaning, if we look at this, we are having 70%, here we are having 20%, and here we are having 10%, you find that now this one we will have 100% of all these, but most of the characteristics that you find here are from the parent. So that is more challenging if you try to understand the real life scenario. And that is why I'm saying, the moment that you'll be coming up with your own system, you need to first of all come up with this inheritance. Which class is inheriting from another? It's like now you are coming up with a database. The moment you are coming up with a database, or the moment you are doing database, mostly Access or maybe DBMS, we are talking about inheritance. But we are not coming up with a class without first of all looking at which class is inheriting from another 100%, so that now we can be able to interlink them. Because when we interlink them, when you delete a parent class, when you delete a parent class, we delete everything. So it's like now when you delete this parent, we delete everything. But when you delete this child, we still have some properties that are left within sister and a brother. So in this case, we are not affecting. That's why when you're coming up with a system or a tree system or a binary tree in programming, we move from bottom up. We move from bottom up. And that's why you can see most of the arrows are pointing upwards, because a parent is the one that is inheriting everything from these classes that we have in the system. So I think you can be able to get what I'm explaining. Is it possible to get what I'm explaining, please? Can we get? Okay. Can we proceed? Can we proceed? Okay, so we can proceed. Maybe, yes. So I think we can proceed to the next one, which is hybrid. And I think hybrid is not new, because we are combining single relationship, multiple relationship, and hierarchical relationship. So when you combine all the attributes together, you form what you call a hybrid. So we can say it is an advancement of this hierarchical. It is an advancement of hierarchical, because most of the attributes you find, even if you have millions of children or millions of classes, all those millions of classes, they have some relationships in them. The next part is what you call generalization. And one of them that we have talked about is what you call the inheritance, but we need to talk about what you call generalization and realization. And in generalization, we are saying there is a class that has all the properties. And this is where we are saying, this is where two or more related classes are brought together to form a more general class. And I think I can use this example because it's very clear. So when you are generalizing, we are saying the shape class is a generalized class, but these are specialized class, because each class is having its own presentation. It's like now we are forming many forms. Circle is a shape. Rectangle is a shape. But most of the operations that are done by a shape are not the same operation that are done by a rectangle. So you find that most of the operations are now differing. But you find for it to be called a shape, it has some characteristics that are dominated from a shape. So in this case, we generalize. So generalization is from bottom to top. And that's why I remember explaining that. And we said when you are using generalization is when you are moving from top to bottom. From top to bottom. And we can say from top to bottom, that is generalization. From bottom to top, that is what you call specialization. Generalization, specialization. So that is one relation. One we can say, the classes that we are having here, parent, sister, brother, and child of your sister. So meaning, this is now a generalized class, but this becomes the specialized class. This becomes the specialized class, because we are saying we can live without brother. We can do away with this, but we cannot do away with the parent. So when you look at that, now this becomes a specialized class, but this becomes a generalized class. And that's why we move from top to bottom when we are now generalizing, and from bottom to top when we are specializing. So in this case, that's why we need to understand specialization. This is the opposite of generalization, and is a case whereby a more specific class is formed or derived from a general class. And I think this is much easier for you to interpret that. Where we have a student person, so there's a specialized class, cashier and employee, they are specialized class, and this becomes the general class, and this becomes another general class. So from bottom to top, that is what you call, from bottom to top, that is what you call specialized class. From top to bottom is what you call generalized class. The next part of inheritance that you always have, and we need to emphasize more on this, because we have other relationships that you find within these classes, is what you call dependency. So one class depends from another. So one class is independent. So we have dependent class and independent class. And I think this is not new to you, because you look at now a dependent class, if you look at where a class cannot live on its own, this class must live with another class, must live, or it is living because of another class. And if you look at this, there is a simple case here, where we are now using some aggregates, because we have said in this specialization or in this dependency, we will be able to look at various dependencies that we have. So we have aggregation, we have another one that is called composition, and those are two main that we have on this category of relationship that we are calling dependency. Meaning, when we are now looking at aggregation, aggregate means it's like we are combining. So a class purely depends on another class for its existence. E.g., a class called premium is an insurance company, can only exist if there is another class called policy. Let's have another example here. Before we go to that example, maybe we can use the symbol. So the symbols that are mostly used for aggregate, for aggregation in dependency. So if you are doing some dependency and we are using aggregate or aggregation dependency, we use this symbol. This is a diamond with a line or an arrow. Meaning, premium, we have policies, but these policies are given as premiums. So a class called premium is an insurance company, can only exist if there is another class called policy. So this premium, maybe we can have health premium, maybe we can have school premium, etc., but now becomes a policy. So this premium will only exist if there is a policy. Right now, if you go to Jubilee Insurance, or maybe you go to Britam Insurance, there are those insurance premiums that are in Britam that are not in Jubilee. So in this case, we can say that policy will never exist if that premium will never exist if the policy is not there. So that premium will never exist. Just take an example here. Maybe we can look at a student. Maybe we have fees. We have fees and maybe health. So we look at health cover. Now we can look at this case. There is one class. So this, we can form an aggregate class. There is one class that cannot exist without another. Health cover cannot exist if the student have not paid the school fees. So you must pay the school fees so that your health cover can be activated. So in this case, if now we are using some presentation of this, we are saying the policy exists because we have premiums. So the premium can only exist because these premiums are there. So if the policy will exist, so this becomes the parent class and this becomes the child class. So in our case here, we can say this becomes the parent and this becomes the child. So the moment you are presenting these, now you can use the diamond to present this. And we say this is an aggregate class, or this is an aggregate dependency, because health is depending from fees, but fees cannot depend from health. That's why you find that those schools that has health facilities inside, like now if you look at JKUAT, it has a hospital inside the university. So if you look at that university, you pay fee every year, every semester you pay 1,000. And when you pay 1,000 every month, so if I have not paid 1,000 in that month, if I fall sick within that semester, I cannot go to that facility. So I must use my own money so that I can cater for that. So that's why we are saying this is an aggregate class. If a class is depending from another class, and that class cannot exist without another. So this health cover cannot exist if the fee is not paid. So that becomes an aggregate dependency. That becomes an aggregate dependency. So I think we can still understand what we are talking about here. Can we still get what we are talking about, please? Can we get? Can we get? Can we get? I'm still waiting for your response so that we can continue, please. Can we get? Are we getting? So I think maybe up to that point, maybe you can understand this aggregation, but I want us, maybe we can complete with this. I want you to go through what we have not tackled today, because the next one we will start from behavioral modeling. But before we call it a day, or maybe we can go to the chat room so that we can try to create some charts, I want to go to what you call composition. So composition is part of what you call dependency and what composes the other. And I think this is a good example where a car engine is composed of a gearbox, carburetor, and we can have what you call piston. So it means this car, if we remove piston, suppose we remove piston, if we remove this piston, this cannot be called a gearbox. It cannot be called a gearbox. So it will be called a gearbox if, it will be called a car engine, sorry. I'm sorry for that. It will be called a car engine if it has gearbox, carburetor, and piston. But if you try to remove this, automatically that cannot be called an engine. So in this case, we are now calling it a composition. And remember, when you're using a composition, we have a difference when you're using it in this. We use a diamond, but inside that diamond, it is shaded. We shade inside it, because now we are presenting it as a what? We are presenting it as a composition. That's why we are saying, as the name suggests, this is a dependence relationship whereby a certain class is composed of other constituent classes. For instance, a class called hygiene. And for this interpretation, we can be able to understand that this class is able to to create some interpretation where when you remove one of them, we will not have a clear agent because we have removed part of the system that we are having. So in this case, we can see composition has now been used as a combination. So we are combining some other classes. And when you combine other classes, we are able to form another class which is more superior than the others. Differentiate using these symbols, where we use a symbol like this, but we don't shade, but the other one we shade when you're using composition. So when you're using composition, we shade, but when you're using aggregation, we don't shade. So that is something that you're supposed to note the moment you are presenting it theoretically. The last one, which is common as part of the relationships, is what you call association. And association is where we say it uses a keyword use. So class A uses class B. So car uses driver. Car uses driver. At the moment we are using this, we don't use arrows. We use a straight line. So the moment we are presenting association, we use a straight line. Meaning, this class is associated with this. How is it associated with this? It is associated with this by one-to-one, many-to-many, and those are the ones that we call cardinalities. So a car associates with the driver. So here we cannot say a car associates with a cook. We cannot say that. That is very wrong. Because a car will never associate with a cook, but a car will associate with the driver. And we use a straight line. And that's why if you look at now, this is where we need to look at now the cardinalities that we can use. And most of the cardinalities that you are supposed to use are 0 to 1, 0 to specified. When you say 0, it means there is none relation to 1. You can have a 0. It's not a must you have a relation, but the maximum should be 1. So this becomes a minimum, and this becomes a maximum. This becomes a minimum, but n now represent many relationships. For this one, represent many relationship with any kind of relationship. It's not a must we have the equal relationship. Like now, a car and a driver. We can have a car and a cook. So in this case, we are using this asterisk. But what I can urge you, when you're using this relationship, just use any kind of relationship that we have, either one-to-one, minute-to-one, or minute-to-many, etc. But there is another one that you use realization. A relationship where one class specifies a contract which the other class commits to fulfill. Now, one class must have a contract. There is a contract. Maybe we can say a teacher has a contract with a student. If I attend a class, that is the time that you say the teacher X attended the class. So we have a contract. So the arrow should point to the contracted person. So who is a contractor? So we are having now here a client and a contractor. So a client requires a contractor to do some work. So meaning a student requires a student to do a card. Requires a student, a teacher requires a student for this person to teach. So in this case, we can say here we can use student, and here the contractor now becomes the contractor now becomes the teacher. The contractor now becomes a teacher, and that's why we are using a shaded arrow. We are using a shaded arrow, and this now becomes the parent. If there is no teacher, this unit will not be taught. So that's why we are saying this becomes the parent class, and this becomes the subclass in that presentation. So we will be able to come up with other examples. I will give you scenarios, and these scenarios you will be able to create some presentation of these relationships that you have already talked about. So you must make sure that you understand them and you go through them so that you can be able to understand what you have already talked about, the relationships. So for now, I want to pause at that point, and I will not start on behavioral. I will start next week on behavioral. Maybe I assume maybe next week we'll not be having your exams, but I am assuming that next week maybe we can have behavioral, because I don't want to mix some other things that we have here. So please, if there is a question, maybe you can ask before we go to the chat room, or maybe we call it a day. Is there any question? Is there any question, please? Is there any question, please?
No.
Yes, Richard. So I think
No.
what I will do for today, I want you to go through the notes that we have already discussed today, because they are more technical. Remember that we must understand the relationships and the relationships that we are supposed to use in a class. Because now, if I introduce another class here, how are we supposed to relate to that class? So please make sure that you understand them. And for today, I want to ask, maybe we can reach at that point. Maybe I give you a break today, so that now, maybe from next week, we can have a recap on what we did on maybe today. So please, if we don't have any question, maybe we can go to the quiz. You do a quiz that I will set there, so that now we can understand what we have covered today. So if there is no other question, maybe we can proceed to the next room. Are we together? So can we proceed? Okay. So there is something that I want to clarify here. I have seen to most of the students who are now doing the January-April exam. Remember, your diploma exam will be done, I think maybe next week or next week, but one, it will be communicated. And I have seen most of the students have not registered for the last semester exam. Please, can you make sure that you register those exams in those units that you did last semester, so that now you'll be able to do your exam if you don't have some issues, please. So we can meet now in the chat room for more clarification on what we have covered, please. Thank you.